So let's say you are seated peacefully in the exam, minding your own business, and they decide to ask you a situation like this one. So it says a pulley system is used to keep a heavy object at rest, as shown on the diagram below. So one thing we see is that we have three forces acting on this object. The first one is the 1,440 newtons, which is a two-dimensional force, and it's acting at an angle of 55 degrees with the horizontal. The second force is the 1,284.95 newtons. It's a two-dimensional force as well, but it's acting at an angle of 40 degrees with the vertical. And one thing you must know is that we never use an angle that is with the vertical, but we always use that which is to the horizontal. So in other words, the correct angle for us to use will be 50 degrees in this case, because we know that the angle from the y-axis to the force is 40 degrees. So it means the angle from the x-axis to the force will simply be 50 because they add up to 90 degrees. That is what you know. Then the last force will be the gravitational force. Because this object is heavy, it means it has mass. So any object that has mass has weight, or the gravitational force, if you like. So let's look at the first question. It says, define the term resultant vector. Well, you can do that. I trust you. The next one says, draw a vector diagram showing the forces acting on the object. Label the forces and indicate the angles on your diagram. So when they say draw a vector diagram, they are referring to the tail to head method. Are we fine? But before we can do the tail to head method, I want us to draw the free body diagram. There's something I want you to see first. So if we talk about a free body diagram, we know that the object is represented as a dot and the forces are represented as arrows pointing away from the dot. So this will be the first vector with a magnitude of 1,284.95 newtons. Then the second vector will be this one. So this one is the 1,440 newtons, like that. And then the last vector is the gravitational force, which is always going directly downwards towards the center of the earth. But if you like, you can say it's the weight. So remember what we said. We said for this force, the correct angle to use is 50 degrees. And then for this one, the angle is 55 degrees. But on your free body diagram, it's not necessary to show the angles. Now it's time to go to the vector diagram. So you can choose which force you want to start with. So let's start with the 1,440 Newton force. So because it's a two-dimensional force and it's acting at an angle, I want you to draw a smaller Cartesian plane. So this is what you say. And then you show us that this is our force, which is acting at an angle like that. Then you say, this is what you will say. And then the angle here is 55 degrees. So remember, we are using the tail to head method. It means at the head of the first vector, we need to draw the tail of the next vector, which is the 1284.95 Newton vector. So because it's a two-dimensional vector as well, I want you to draw another smaller Cartesian plane there. And then maybe we can use a different color for this one. So we say this one is acting at an angle of 50 degrees with the horizontal. Of course, you must label your forces as they said. So it's 1284.95 newtons. Because you don't know what is the name of this force. They didn't tell us it's F1, F2, or what. Right. And then this one, we said it's the 1440 Newton force. Then we still have another vector, which is the third one. We said it's the gravitational force, and it's always going downwards like that. So this is how it will look like. And then you say that. Do you see that? You don't know the magnitude of the weight, so you label it as Fg or as small case w. Small case. I wanted to say lowercase w, but let's just say small letter w to make life easy for everyone. So this is how your diagram will look like. Of course, you'll come and label the angle here as 50 degrees, like that. Tail to head method. At the head of the first vector, you put the tail of the next vector. At the head of this vector, you put the tail of the next vector. Now, this is what you must know. If the head of the last vector is directly linked to the tail of the first vector, then you must know that the net force acting on this object is 0. The resultant force, that is. But this is not the diagram they wanted you to draw in terms of the angles. They want you to show the angles that are inside the figure. Do you see that? So here we need to use quick Euclidean geometry in order to fill this diagram with the angles. So one thing we know is that since gravity is a vertical force, so we can say it's the y-axis. Now the angle between the y-axis and the x-axis is simply 90 degrees. So this means 90 degrees minus 55 will simply be 35 degrees. Awesome. But if you look at these two portions, we have two Cartesian planes. So we can say this is the horizontal plane. This is another horizontal plane. And then we see we have a Z shape there. So we think of alternating angles. So this means the angle here is 55 degrees. Great stuff. Now, if you add these two angles up, you get 105 degrees. So then, what is the size of this one? Well, in order for us to get that size, we use the sum of angles of a triangle. So we say 180 degrees minus 105 degrees minus 35 degrees. Then we find that the angle here is simply 40 degrees. So what is the correct diagram for you to draw? Well, you'll say, this is what you have. Or maybe we should use a different color. Black is ideal. So we say this is the first vector, like that. And then you say this is the next vector, like that. And then you say the third vector will simply go directly downwards, and then it's going to join with the tail of the first vector. So you label this as FG, and then you label this as 1284.95 newtons. And then you say 1440 newtons, like that. Then you show us the angle here is 35 degrees. Here it's 105 degrees. And this one here is simply 40 degrees. So this is the correct test of the correct diagram. No, I'm not saying this is wrong. So this is the simplest way to do it. This is actually how you start to do it. But these are actually the same thing. Right. So let's look at the next question, which is the last one. So the last question says, calculate the weight of the object. So weight, we know it's the gravitational force. So because gravity is a vertical force, we need to consider vertical forces only. So what do I mean by that? We need to resolve the 1440 Newton force, but we want to find its component that is vertical. We also need to resolve the 1284.95 Newton force so that we find its vertical component. So one thing we know is that, let's do another free body diagram. So let's say this one will simply be, maybe if the 1440 Newton force was F1, then we would have F1 in the Y. And then if maybe this one was F2, then here we would have F2 in the Y. And then here we'll have our gravitational force. This is how we would have it. But because we are not given the notation, we are not given F1 and F2, then this is how we say it. Because they told us that the object is at rest, it means the net force acting on this object will be 0, both horizontally and vertically. So we focus on the vertical forces. So we say the net force of the vertical forces will be the vertical component of 1440 newtons, which we obtain by saying 1440 sine 55 degrees. This is what we say. So it's positive because it's going upwards. Then we say plus. We take the vertical component of 1284.95 newtons. But we obtain this by taking the magnitude of the force and multiplying it by the sine of the angle. And then we say plus. The gravitational force is going downwards, so we say it's negative. And everything is equal to 0. So if you go to your calculator and say 1440 sine 55 degrees plus 1284.95 sine 50 degrees, you are simply going to get 2163 0.91. And then you say minus Fg equals 0. Then if you take gravitational force to the right, it's going to become positive. So this means the magnitude of the weight will be 2,163.91 newtons. And then your happiness is complete. The most important thing, gravity is a vertical force. So we only consider vertical forces. Over and out.